Warm greetings to all of you. So myself Gunanandini. I'm here to share a few words about digital electronics. So I'm from KPR Institute of Engineering and Technology from the Department of ECE. So now the human can understand only the analog language, whereas the machine will understand only the digital language. So here the conversion must takes place an important one. So the ADC conversion, which means analog to digital conversion, will help the convert analog input into the digital system, which can be understood by the computers. And finally, the human understand only the analog things. So that conversion can be takes parts by DAC, which is analog to switches, or which is digital to analog conversions. Whereas your analog output, where we can hear and concentrate everything in the analog terms. And now this is the clock which will represent the digital values. So this format can be called as the 8421 format. So the now time, the time which is representing in your board is 8 hours 5 minutes. So this 8 can be written by using in terms of 8421 console 1000, which is a hard format, and this 0101 which this minute can be represented by means of also 8421 concept. Here 8421, so 4 they have represented 1 at the place of 4, and at the place of 1 they have represented 1. So 4 plus 1 totally 5. So this is how the analog and digital clock will. So this block will represent the digital system, how the subsystem involved in that, and what are the models they have used for converting the things, and the basic units logic gates were used, and the circuits involved in this digital electronics. So generally, the basic units can be made up of some logic gates, which is AND or NOT, NAND, NOT, XOR, XNOR. This will be learned in next previous sessions. So the next is binary number system. It has the base of 2, which is this can be called as the radix of the binary number system. Here next comes the octal number system. It has the base of 8, and hexadecimal it has the base of 16. So now the decimal number system, will see how the conversion can take place. Here we already know that decimal has the base of 10. So the 10 means from starting from 0 to 9. The characters in the set is totally 10. That is why they represented the base as 10. So for example, they have given 7392 with the base of 10. This 10 will represent the decimal representation. So this is the ones place, tens, hundreds and thousands place. If this thousands place means we have to multiply with the 10 to the power of 3, because it is represented in the thousands place, which is the least significant bit. This is how the conversion will takes place. So next one will be octal number representation. Generally octal will have the basic of 8, which is the radix. Here comes the characters in the set is 0 to 7. So as usual formula, 0 to or minus 1, or r is 8. So 8 minus 1, 7. So total set in this character is 0 to 7. So the ways with the representation of 8 will represent the octal number. We have to multiply it with the 8 to the power of 3, which is at the thousands positions. At the tens, the ones position, 8 to the power of 0. As like the same in the previous binary representation, the fractional part will takes in minus. So 8 to the power minus 1, minus 2, minus 3. It has to start from minus 1, minus 2, minus 3 from left to right, and 0, 1, 2, 3 from right to left. This is how the conversion will takes place. So the next is hexadecimal representation. So this can be represented in the base of 16. So totally, as like before, 0 to or minus 1, 16 minus 1, 15. So totally 0 to 9, and then 10 can be represented in terms of A, 11B, 12C, 13D, 14E, 15F. So 11 we cannot represent. So this is how the hexadecimal takes place. The 11 replacement is B. A to F we have to represent. So the 16 will represent the base of hexadecimal. So 3FB. So 3 can be multiplied with 16 into 2. So plus F, the replacement is 15. So F into 16 into 1, and then D into 16 into 0. As like previous, the fractional part can be of start from minus 1, minus 2, left to right, and this thing will start from right to left 0 1 2.